Okay, welcome to our presentations. Today we will see some assignments on final element analysis. Those assignments are basic for every master student. So we will see some parts of the questions. Question number one says that the truss is fixed in the left, and the load is unknown load is applied on two upright joints. It is made up of wood with the Young modulus of 16 gigapascals or parallel to the fiber, and cross-sectional area. The given cross-sectional areas are for each beam. A fixed truss is 25 centimeter squares. Compute the displacement at each node is element force and reaction force. Also the stress in each element and using finite elements method workout also using access and verify your results. The given equations or the given beams are like here. These beams are given, these trusses are given. At the 2 point or notice node number 1 and number 3, the trusses are fixed trusses. Then at node number 4, the applied loads or the given loads are downward. Negative shows us the directions of the applied loads 650 kilonewtons. At node number 5, the given load is also 650 kilonewtons. The distance between joint number 2 or node number 2 to number 4 and number 5 is given 1 millimeters. Then the distance between node number 2 to number 5 in here 1 meters. This is also 1 meters. Then for calculating these trusses, we should be divided into element number 1, number 2, number 3, number 6, 4, 5. As you went, you can, or as a desired assignment, you can divide it truss into elements for calculation. Then using the solutions of this one is like this. Solution, given data analysis. The given data should be taken out at node number 1, node pair and elements. So node pair means node number 1 to 2, number 1 to 2, these we take as element number 1. Node number 3 to 2 to 3 means 2 to 3 we take as element number 2. Node number 3 to 4 we take as element number 3. Node number 4 to 2 we take as element number 4. Node number 2 to 5 we take as element number 5. And for node 5 to 4 we take as node number 6, which means you can analyze, you can see from this 1 to 2 element number 1, 2 to 3 element number 2, 3 to 4 element number 3, 4 to 5 element number 6, 2 to 4 element number 4, 2 to 5 element number 5. We divide this one into here. The other given is Young modulus of the wood material given 16 gigapascals. Convert into kilonewton per meter square because this one the lengths are given in meters. The length is 1 meter. We should be converted the gigapascal into kilonewton per meter square. The given area is equal to 25 centimeter squares. We convert into millimeters, 0.25 meter squares. The load at point number 4 and 5. Point number 1 equal to 650 kilonewton. This one. No, P1 means not point number 4 and number 5. Downward direction shows that negative of this one. So The element number 1 is straight line, node 1 to 2. The displacement on here is u1 y upward, u1 x in the directions of x axis. So in point number 2, u2 y upward, u2x. This one. So after that we calculate the theta is given. Theta 0 degree means this one is on horizontal degree, so straight line. Horizontal degree, so the angles are 0 degree. Cos of 0 1, cosine, cos times sine, which means cos of 0 times sine of 0 equal to 0, sine of 0 equal to 0, cosine square. Cos of 0 is 1, cosine square is 1, sine square 0 times 0, 0. Then area is given, angle is given, length of the element is given. So we should be convert this one into these diagrams. Stiffness number 1, stiffness element number 1 is equal to angle times area divided by length times this matrix times the displacement, applied displacement. This one is a formula. So those are general formula for these calculations. We substitute those values in here. Then we get such like results are developed through calculations. The result of this one for the 1000 is come from your result. The displacement is u1x, u1y, u2x, u2y. The displacement is at point number 1 and point number 2 are written in like this one. Then for element number 2 is inclined. This is point number 2, point number 3. This one is inclined in like this. This area is given, the angle modulus is given, the length of the element. We should be calculate the length of the element. The length is 2 here, 1, point number 2 to number 3. Then the inclination angle of this object is 135. This one is not given. We get through calculations of the beam. Then after that the calculation we get the length of these ones. Calculate this result by yourself. Then we get length is equals to 1 millimeter over cosine of 145, which means 35 divided by this one's minimize from 360 degree we minus this one. Okay, 45 0 70 270 90 degrees left from that. Then the angle modulus is calculated in here. For element number 3 it is straight line, theta is equal to 0. Similarly with equation in element number 1 we can generate every data in like these ones. For element number 4 it is 90 degree, it's 90 degree, so theta is 90 degree. Then we generate the stiffness matrix in like this one. Element number 2 stiffness. For element number 2 stiffness, theta is equal to 135. So the generation of this result is like. For element number 5, similar to that, the opposite of that angles are what? 45 degree. The inclination of this one is 45 degree. So we generate this one's stiffness of the element number 5 like this one's. For element number 6 it is on a straight line, theta equal to 0 degree. We generate like here the theta of the stiffness of the element for element number 6. Then at number 6 we have displacement number 4x, displacement number 4y, displacement number 5x, displacement number 5y. Similarly, we can reduce this formula, this equation into this. Then the global stiffness of the matrix is the summation of all matrices. So stiffness number 1 plus stiffness number 2 plus stiffness number 3 plus stiffness number 4 plus stiffness number 5. We get the global stiffness of the matrices. Then the results of them are calculated like this. So we take these tables and assembles of the 5 stiffnesses. We assemble like here. Every ones are written on their positions. Then they are written in like this one. We eliminate these ones. Around this one, we have no this data. We have no this data. We eliminate them because they have no forces at those points. After eliminations, we should be determine the boundary conditions. U1x equal to U1y equal to U3x equal to U3y, because we have no displacements on this point. They are fixed at point number 1 and number 3. Then reduction stiffness are like this one. It is reduced into this. Kg means global stiffness matrices are written these equations. Then global equations are given by global stiffness matrix times displacement equal to reaction force. The force are given. Then from global stiffness matrices we generate those equations. Or F2x is not given. We have F2y. The force on x directions are 0 because they are not given. We take equation 1 from this one. We should be generate times this one. Kg we have, displacement we have, force we write in here. Then we got those 6 equations. Equation number 1, 2, 3, 4, 5, 6 are depending on that. Then from equation number 3, from equation number 3, 0 means the force on the x directions are not given. This negative 650 means the loads are given on point number 4 in the directions of negative y directions. On number 5 also we have the direction shows that in downward direction. Then on f5x we have 0. This one is 0. Not given. So from equation number 3, from here we reduce this as 80,000 times u4x plus negative of 40,000 times u5x equal to 0. F4x equal to 0. Then we reduce these ones. These equations are reduced into u4x equal to half of u5x. The displacement is on point number 4 on the x direction equal to half of the displacement is on point number 5 in the direction of x. So from equation number 4, from here equations, we add these equations, then we get this results. Then after we are adding and minimizing, rearranging the equations, we get equation number 8. Equation number 8 says that u2y equal to 650 plus 40,000 u4y divided by 40,000. So from equation number 5 and 6, multiplying equation number 6 by -1 and simplify simultaneously. This one is shows us the simultaneous equation summations of reducing the equations by simultaneous equations. So equation number 5 is these equations, and equation number 6 is these equations we take from the table. So after rearrangements, we get these equations. Remaining equations are reduced to here, u4x equal to 650 over 14,000 minus u5x. Then it is reduced to here. This equation is we take as equation number 9. Then from equation 7, substituting equation 7 in equation 9. Equation 7 in equation 9. Equation 7 says that what? Equation 7, where we take equation 7. Equation 7 is this one. u4x equal to half of u5x. So this one is equation 7. Half of u5x means equation 4. So the equation equal to u5x minus 600 is this one. When we are dividing this one by this one, we get this one. Then half of u5x equal to u5x minus this result divided by 2 multiplied by 2. This one. Then it is x when we get displacement at point number 5 in the x direction equal to 0.0325 meters in meter displacement. Solving equation number 5 and equation displacement is number 4 at point 4 on the x direction. From equation 7 we get u4x also. Then from equation 1 and 5 you can check equation 1 and 5. Equation 1 is this one and equation 5 is this one. By using the simultaneous equations, then we add these ones. We get this equation number 10, u2x equal to this result. Substituting ux in equation number 5. In equation number 5, then we get these results. Then this one is equation number 5. Substitute this one in here because 2 ux is the values of 2ux equal to this one. Then we are rearranging these equations like this one. After that we will get this equation, that is equation number 11. From equation 8, that will be equation number 8, u2y equal to this ones. From equation number 11, u2y, this one equal to this one. Okay, then we minimize equation this one. We get u5y equal to these results. Then from this one u2y equal to this one. Rearranging substitutions equation number 11 and 12. This equation in equation number 2 is solving for equations. By using substitutions we are generating this result, equation number 11 and number 12. So we get at the end this result, 2uy equal to 0.14 meter. Then we get u4y equal to u2y minus this from equation 9 or 10. We get this one u4y we get u5y also we get it u5y from u4y. Then the negative direction shows that it is compressive. Displacements are compressive. When positive, it is on tension. Then equation displacement is on number 2 on the directions of x. Point number 2 or node number 2 on the directions of x. It's negative. It's compressive stress. Generally, displacements are calculated like this one. On point number 3 and 1 or node number 1 and the number 3 we have no displacement because it is fixed. So the displacement is on the fixed points are 0, but this one is on the movable. Displacement is on at node number 2 in the x direction negative, in the y direction also negative. Displacement is on number 4, nodal number 4, on the x direction it is positive, on the y direction it is compressive negative. On point number 5, nodal number 5, we have displacement also on the x directions and displacement is on the y directions, the negative displacements. Then reaction force of those are calculated by these equations are from the global matrix. Question number 1. Then we substitute instead of the displacements what we are get in here. Then we get reaction forces at point number 1 equal to this one on the x directions. On the y directions also we are generating these displacements. Say this one is artii reactions, not 1, 2. This one is reaction 2 on the x directions. This one is reaction 2, 1 on the x direction. Similarly, we get reaction 2 on the y direction, reaction 3 on the y direction or the x direction also. We generate all reaction forces by using this method. The left one is element force, stress, strain, and changes of displacement should be calculated. So change of displacement means the displacement from node number 1 to number 2 to 1, or when the objects are from number movements, free movements are at rest, from node number 2 to number 1 we should be calculate the change of displacement. So change of displacement means at point number 1 from 1 to 2 displacement number 2 on the x direction minus displacement number 1 on the x direction. So in here we have displacement is on the point number 2 on the x direction, this one is 0. So we get the result change of n displacement. Negative shows that compressive. The stress is equal to strain times young mobility and mobility given. Stress means strain means change of n given, change of n means calculate this one. We substitute increment 1 millimeter. For example, in this, then we get strain. Stress is equal to strain times young mobility given times young mobility given. On the equation, we get stresses on point number 1. Then the force or element force of the object should be calculated. Element force is equal to, we know stress is equal to force of area. So element force is equal to stresses times the area of the object. Stresses is calculated, but in here then times area of the object area are given on the above. So we get element forces in kilonewton. For element number 2, similarly we are calculating change of L also. Change over where we are calculating the change over. This one is inclined on the inclined, not on the straight line. So then we should be calculating like this one. This one is 0 means displacement is on number 0.30. This one is 0. We have now This one also 0. This one is 0. This is u3y 0. Then sign of angle is no matter 0 times any number is 0. Then we have this one and this one. Substituting the values of 2xy and 2y1, 2y u2y. Then we get the result is by the angle of this one is 135 degrees. Then we get change of L. This one is change of L over 1 L is equal to strain. We get strain. Then from that we can easily calculate the stress of the object is also. This one is stress. Then reaction force is equal to stress times area. No, element force is equal to stress times area. We get the element forces on element number 2. Similarly, for number 3, the reaction force, stresses and strain or element forces are calculated in change of L is equal to strain. Change of L number 3 for element number 3. It is a horizontally. We get this one is 0. We have this one substitute directly. Similarly, we generate element number 4, stress, strain, and element force also. Like this one. Easily we get all the values for element number 5. Element number 5 is not horizontal or it is inclined one. Then we have this one, this one also we have. Substitute directly, use angle of the inclination angle is 45 degree. Then we get change of L. This. Then element force for element number 5 equal to this one. This one stresses. After that we get element forces. This element force for number 5. Number 6 is similar. This is a horizontal. Directly change of this one is we get this one. Similarly, strain, stresses, element force for element number 6. Thank you. Solution of question number 1 is like this. Thank you for your listening. For question number 2 says that question number 2 for the plane traces shown in a figure below determine the nodal displacements, elements, forces and stresses and support reaction using the finite element analysis. In this we are not showing finite element analysis. We use finite element analysis by the hand. If it is necessary, you should be compare and contrast. After calculation, you should be use software also. Then the given equations, the Young modulus are given, areas of the elements are given. Number 4, node verify force equations at node number 2 and number 4 using symmetries of the record in your model. Given data. This one is the figure. What are given? This figure is given. So this one is using the symmetric method. Symmetric methods are used to divide these sections are similar to with these sections. We divide this one at point number 3 and 4 by using symmetric model method. So after symmetric model, this one is divided into like this one. At this point, we take as a roller movement downward and upward. These objects are moved, but on the x direction they are fixed after operation or symmetric method. Then area number 3 to 4, these are sections. These one have symmetric form. Due to symmetric, we divided by 3 times the area divided into 2 because these sections are sectioned. Symmetrical rule, the area is minimized half of the first one, half of this one is really half of this one. So divided into 2. Those data are given, areas are given. First area we minimize this area we take this area. These areas are given, but after symmetric method, we should take half of the given area. Half of the given area. Then young individuals are given using half of the symmetric structure. By symmetric half of this one, we take calculate on this one. After calculations, this one converting the given gigapascal, young individuals in gigapascal into Newton per meter square area of this object. We take this one, but we take half of this one. Length is equal to the length of the object. This one. Okay, 3 millimeter divided by 45 means the inclination angle. Inclination angle of this object. For element number 3. Element number 3 means this one, this element. Okay, the length of this one is 3 millimeter. This one is 1 millimeter is given. After Pythagoras theorem, we get this area. Okay, Pythagoras, by using Pythagoras theorem, element number 3 means these sections by using Pythagoras theorem. Okay, after that the length of the inclined length, this length equal to this length. Then element number 1, 2, 4, we calculate for this one the same stiffness for the other or the section, the area. Then, which means for element number 1 and element number 2 and element number 4. From the diagram, see 1, element number 2 and 4. They are equal. Section. Case of this one is equal. Then after calculations we get this result is okay. Stiffness for number 6 is calculated like here. Stiffness for number 3 and 5 equal. Then we get this. Okay, for element number 1, theta is 90 degree. You should be calculate this one. Then the displacement stiffness of these objects are given like here. This one is given. After calculation, after we inserting the given theta 90 degree in here, we get this result. Those results times the displacement at that point. For element number 2, is horizontal. The length is 3 meter. The displacement is on. This one is u1y, u1x, u3y, u3x. X direction shows that the x shows the direction on the x respect to x. The y shows us the direction with respect to y. Then K2 stiffness for element number 2. After calculation we get then it is on horizontal 0 degree. We generate this result. Similarly, this one is at inclined for element number 3. It's 0.223. This length is after calculation we get 4.24 meter. Then the point at point 1, the displacement is on x direction is 2x, 2y. Displacement at here is on y on x directions. After that, the angle of this one is theta is 315 degree. 315 degree, the inclined angle. Then cosine square of this one is this one. Sine square of this one is 1 over 2. Cos times sine of this one is negative. You calculate this one. You should be getting this one. The given theta is 315 degrees. Then you can directly get those results. After that, you insert in here. We get those results. After reduction, this one is half of this one divided by 2 times this one by 2. So when we get those numbers. Then For element number 4, this horizontal theta is 0 degree. Similarly, with that we get those. For element number 5, this the given angle is 45 degree inclined. After calculation, you get this angle. Then those results are generated. For element number 6, 90 degree. Then we get due to symmetry. Areas of this one is half of the area we take. Half of the area, our point here is on a symmetric. Half of this section 1/2 times the given area. Then we get this. This one is calculated. To find the global stiffness matrix is like this one. Stiffness matrix Kg equal to global stiffness matrix equal to K1 for element number 1 plus K2 for element number 2 plus K3 for element number 3 plus K4 for element number 4 and for number 5 and number 6. The assemblies of those are like this. Assemblies of 4 and 6 are like these ones. For element number 1, number 3 with Q, 3 with 4. This one at point we inserted then 0 0 means not integrated in here. Not integrated in here. But it is not vacance. Connections are not disconnected to this one. This one is connected. This one is connected in here. Then the tables are generated based on the given. We determine the boundaries of the objects. Boundaries of the object. U1 on the x direction is fixed. U1 on the y direction is fixed. This one is stationary or fixed. U3 on the x direction is 0. U4 on the y direction is x direction is 0 from this diagram. From the diagram. So on the x direction at 3 and 4 it is fixed. The roller are on the y direction, moving on the y direction only. At this one, u4x is 0, u3x is also 0. It is stationary. Due to that reasons, we take 0 at a boundary condition. So on the y and at point number 1 also it is stationary. Then they are 0. From that, K is reduced to global stiffness matrix is reduced to this. Then global coefficients are given by global stiffness matrix times displacement equal to forces. Given forces. Those forces are given at point number 2 and number 4 only. They are given the y directions, negative y direction. Then we reduce those equations by using matrix multiplications. These horizontal rows times with this column equal to this area, these forces. These forces are not given on x direction. On x direction we have no force, 0. We take. Then equation number 1 are generated like this ones. Equation number 2 are generated from this one times this one equal to this one. Y 2y f equal to negative of 60 degree. Then we generate equation number 2, 3, 4 like here. 4, 1, 2, 3, 4. Equations are developed. From equation number 4, this equation, okay, we minimize these, we take these ones, okay, on the 4, f4y equal to negative 60, we reduce this u4y in like this one. Let's say equation number 4, this equation is, we say equation number 4, or the reductions of equation number 4, this one. Then from equation 4 to 3, from equation 2 to 3, this equation, we minimize. This one is equation number 2, this one is equation number 3, it is minimized to this one. U2, this one is 0 means fixed. See, this one is fixed, 0. U4y, we have, okay, Then we get u for y. Substituting equation. So this was 4 in equation number 5 in here. This one is u for y. What we get on equation number 4. Substitution is done in here. After that, the equation is reduced to equation number 6. u3y equal to negative 4.8 times this one. This equation is equation number 6. From equation number 2, 1 and 2, simplify symmetric simultaneously. Then equation number 1 and 2 given a is reduced to this. Then we get equation number 7. Substituting equation number 6 and 7 in equation number 1. 6 and 7 in equation number 1. In here. Solving for displacements. Then substituting equation 6 and 7 in equation number 1. Solving means this one. We get equation number 1 is this one. Then substituting equation number 6 and 7. 7 and 6. We give our reduced that equations. After reductions, we get 2y u2y. Negative shows that the displacements are on compression. On compression. The direction also shows that this one. After that, we get this result. Those displacements are calculated like here. By substituting those all displacements, we get all displacements. The displacements of the object, the movement of the object, like these equations are used for all calculating the displacements. Then, therefore, those displacements we have 4 displacements: u2x, u2y, u3y, u4y. For element number 1, we calculate stress of also change. Stress means changes of the displacements. Then we get stress. Strain also the element force also similar with equation number 1. Compression negative shows that the negative of this one is on the negative. We have a negative here. For that reason, we say compression. The element forces on the compression. Reaction forces on the compression. Reaction force number 1 to 2. 4 elements. That's point we get. The elements reduction force and stress analysis as this one is a formula. From that we get those results. Similar these processes are done. We get all reaction force, stress, and element forces also calculated like in here. Element force for 2 to 3 equal to 3 to 6. Similar. This one is symmetric. This one and this one are symmetric to each other. For element number 4, similar we get change of elements, strain, stress also. We develop everything is C shows that the compressive. It's negative. For element number 5, we also calculated. For element number 6, similarly, we're doing this process. Then we use the symbols of K times displacement times global stiffness times displacement times equal to force. This one is general equations of this one. From that, we substitute all the data we have. We get this react element force at point number 1 on the x direction. We get or y also we get. Everything is are done with similar process. So you can see everyone like here. You can doing everyone like this ones. For question number 3 and 4, we will see in the future. Thank you for your attention. Thank you. Have a nice day.